the tricks in this problem is to understand you don't need to go through and kind of micromanage the information in the problem. It tells you that the circumference is 36 of the large circle. That doesn't mean that you have to plug that into an equation and find the radius, just because they tell you that the radius of the small circle is half that of the larger one. And just use ratio of parts. Okay, so if you know that the ratio of parts of any two figures are the same, okay, so again, you've probably learned it as m to n. And that means any one-dimensional measurements have that same ratio. So if the circumferences, or I'm sorry, if the radii have a ratio of parts of m to n, that means any other one-dimensional measurement, which includes the circumference, has that same ratio. So what that means is if the circumference of this large outer circle is 36, what's the circumference of this inner circle? The radius is half, then it means the circumference also is going to be half. Okay? So when you're looking to solve this, what you can do is take the arc length formula, okay, which is designated by an S, is m over 360 times circumference. And now you can either use 2 pi r, or you can use d pi, or you can use just the value c for this equation. So since they tell you what the circumference is, we can go ahead and use that. So you get the equation, your angle measure, or arc measure, which is equivalent to the central angle, so 80 degrees over 360 times the circumference, which is 18. Okay, and now you could just a matter of calculating. Okay, and so if you look at this, 18 goes into 36 twice, 2 goes into 8 4 times, so your answer winds up being D.